Hello everyone, welcome to Scottish Summit. My name is Wagner Silveira and I'm going to be presenting message patterns with AIS. Before we start, we'd like to say thanks to our sponsors, Script Runner, DQ Global, Proximo 3, Red Spire, Agilicis, and Hitachi Solutions. So, as I said, my name is Wagner Silveira and I work in Theta in New Zealand as an integration practice lead. If you wanted to get in touch with me, you can reach me on Twitter on WSilveiraNZ. Okay, so for our agenda today, we're going to talk in a little bit about messaging and Azure Integration Services, so how they fit together. Then we're going to be talking about implementing messages patterns in AIS, how we can actually work with those systems and technologies to put together some well-known patterns. Then we're going to show some demos, and then a little summary. Starting with the messaging and Azure Integration Services. Well, first things first. Let's try to define what are messages and what are events. Okay? So the idea of messages are a set of components that are, or a set of information that you wanted to pass between systems. But one of the properties of those messages, they are transactional. That means that the order that they're going to be processing and how they're going to be processed matters. So that means that there is some expectations with handling those messages. We needed to understand how we're going to be working with them. And also because of that, the order matters, right? So putting messages in different orders might have different effects in the end. The messages can also relate to each other. So there is a chance where a message that you're receiving might be processing order, and later on you have some updates on that processing order. So those two messages are going to be related. So you need it. That's exactly why we have some expectations on how to handle and why the order, why those message arrives matters. From an event point of view, the events are mainly informational. Something happened on my system. If you are interested on that, here is the details of that event. The system that is emitting those events, they don't assume how the events are going to be handled. To be honest, it doesn't even assume that it's going to be handled. It's just telling for people or for systems that something happened on my system. Because of that, the orders of the events don't necessarily matter. Because they are individually important, because they needed to be processed in a specific by themselves. So what about streams? This is kind of the third type of messaging type that you can find. You can usually find messages, events, and streams inside of a messaging system. So the idea of streams is a series of discrete messages, but the group of messages together, or the list of the trend of those messages over time is more important than the message specifically. We're not going to be treating streams on that one. We usually have a set of different patterns for streams. So the patterns that we're going to be discussing here are mostly be used by messaging and events, but not necessarily by streams. Now let's talk a little bit about the AIS Messaging Services and how they related to those types of message that we discussed before. So you have Azure Service Bus, which is the messaging engine, and you have Azure Event Grids, that is your event broker. So Azure Service Bus manages messages, right? So it receives what we call their messages before. It allows you to work with queues or with topics and subscriptions, And the main things, the main difference between those two is that a queue is a series of messages and using the typical first in, first out, right? So it's a repository for messages that needed to be received and processed in order, because that's how messages are processed, right? While topic and subscriptions is the idea of giving you the ability to multicast messages. So you receive a message on a topic, and everyone that's interested on that topic receives a copy of the message. But when that message goes to one of what we call subscriptions, that is, the people that is interested on those messages, the message still goes in order and is still processed in order. The other thing that is quite interesting to understand from Service Bus is the messages are pulled from the client. That means that the client has the ability to decide when it's going to be bringing up the messages and the way that they're going to be processing. That is going to be quite important if you have systems that needs to process messages on its own pace. And AIS Messaging Services guarantees at least once delivery. That means that the message can be delivered once to the system, and in some cases, if it doesn't come back on a specific time saying, yes, I processed that message completely, you can remove it from the queue, it might happen again. It's different from what you're going to see from Azure Event Grids. So on the other side, Azure Event Grids has a broker, is a broker of events. So what it does is be the man in the middle between people that is publishing events and people that is interested in receiving those events. So doing that, you guarantee that the system that is publishing the events doesn't have to manage all the burden to find out everyone that is interested in those services, guarantee that those events has been delivered to the systems. The only thing it needs to do is send events. It also uses the idea of topics and subscriptions like Azure Service Bus, which is basically using the pub-sub pattern that we're going to discuss later on. But the idea is the publisher or events push the messages into topics, and subscribers of the event registers and webhook to those events, and every time that a new event arrives on that topic, Azure Event Grids goes through a list of everyone that is subscribed to that and push the messages to the subscription. Right? It's different from the Azure Service Bus, where clients need to go and connect to that. On this one, the Azure Event Grids is responsible to push the messages. The other thing that is quite important in this case is that what we have there is the idea of at most once delivery. So as soon as the message goes to the service that is subscribing, and that service returns saying, yes, I received the message, it doesn't wait to confirm that the message has been processed successfully. That becomes a problem of the other system. So it can still retry if the connectivity doesn't exist, but once you have that returning, yes, I received the message, it finished at that point. Okay. So next, let's talk about how the other AIS services fits. You know that the AIS offering is not just the messaging components, right? You have other things like Azure Logic Apps, and how Azure Logic Apps support the messaging patterns in those cases. One of the main things that Azure Logic Apps will do is create the idea of service composition. So make sure that multiple components are working together to create like a broader kind of service, or service orchestration. making sure that different systems are called in order to have a specific outcome. And the other component that is quite useful in AIS when you're talking about those patterns is the Azure API management. In this case, it will give you the service that we're going to be taking out of that is idea of API composition. So grabbing multiple services or multiple components on the back end or behind the scenes and compose one unique endpoint for you to call. And create the idea of a service interface. So you have one place to call that is unique and you know how to call, right? And behind the scenes you have like a multitude of other services. Now that you understand a little bit about the messaging and how those services hang on together, let's try to think about some of the very common messaging patterns and how those patterns fit into the AIS model, or how can you use the components on AIS to create those patterns. So the first service, or the first pattern that we're going to be talking about is the publisher subscriber. On a normal messaging system, you have a sender, you have a message engine, and you have a receiver. Messages comes from the sender, goes to the message ender, receiver picks up those messages, or depending on the receiver, the message engine sends it to the receiver. Sorry, depending on the type of message or event application that we use. But what happens if the same message all of a sudden needs to go to two systems? And that's exactly where you needed to change your message engine to be able to multicast that. And that's where the idea of topic and subscriptions comes in place, right? So now what you have is, you as a publisher have a message, and you want that message to go and be pushed in two copies, one for the subscription A and one for the subscription B. That means that now the message engine needs a way internally to generate the idea of one entry point with multiple outbound locations or multiple outbound channels. And we already hinted about that. AIS implementation for that is pretty much out of the box. When you're looking at Azure Service Bus, you have the idea of topics and subscriptions, and the topics and subscriptions are created and managed by the engine. So one thing to be important to understand here is that behind the scenes from Azure Service Bus, the engine creates a queue for each one of the subscriptions. So even though you might receive multiple messages on the topic, and each one of those messages can go to different parts of the subscriptions, or can go to different subscribers, when it gets to those subscribers, you still have the same order that the messages arrive originally. While on Azure Event Grid, we also have the idea of the topics and subscriptions. And the event handlers subscribe for events. What we call an event handlers here. Event handlers in this case is a set of webhooks. So you register a webhook into Event Grid and say, when a new event of this particular type arrives, with this particular definition, please send me a copy of that. And Event Grid pushes the message to those handlers. Once the message arrives safely at the handler, the Event Grid finishes his processing. While on Azure Service Bus, depending on how you code your client, you can say only complete the transaction, only remove the message from the queue, once I tell you that I processed that successfully. Those are the two differences that we saw before between the client handling and the at least once delivery and at most once delivery. So now that we can see how the publish subscriber works, which is kind of quite basic pattern that we're going to be using in other places, we can go to the next one. So the next one that we have is the content-based routing. It's all good that if I receive one message, I can now push that to two different systems. But what happens if now I have a subscriber that is interested on message of a specific type, but only if it has a property of green, and another one that is also quite interested on messages of a particular type that is coming through a topic, but only if it comes with the property blue. Now I needed to create some kind of filter on that channel that we described before to be able to do that. Right? So the idea is now that when I'm receiving a green message with a green property, it only flows to subscriber A. And if I receive a message with a blue property, it only goes to subscriber B. Okay? AIS can also implement that relatively simply. And let's see how it works. On Azure Service Bus, you have the ability to create subscriptions filters. So not only you're able to say messages arriving on this topic I'm interested on, but only give messages on this topic if it matches a set of particular properties. Maybe it's the message type, maybe is something on my property bag, maybe is the sender, that is a specific one. So you can define that. One thing that is quite interesting and is still kind of relatively new, until 6 months ago, you wouldn't be able to actually create those subscriptions directly on the Azure portal. Now you have a very good way and a quite streamlined way to filter and see what is the filters associated to a specific subscription inside the portal. Right? That has been one of the updates of the whole process that we saw from the portal experience. On Azure Event Grids, we have a similar process. We also have subscriptions filters, and it can also be edited and updated in the portal. So what we see so far is that until now, most of the patterns that we looking at are patterns that are quite useful, and because they are so common, they are already baked into the services itself. But then the next pattern, you're going to see that now we needed to actually create a better way to handle that than just what is out of the box. So the next pattern that we're talking now is the client check pattern. The idea is now I have a message that for some reason, either because the message is too big to go through the message engine, since each one of those engines has some kind of the maximum size of the process, or because I don't want it to go and make multiple copies of that message when I'm working with a topic and subscription. For example, I just wanted to keep one copy and make sure that other systems that are interested of that can still process that thing in a transactional way, but just receive a copy of the payload to then process, or because of data sovereignty issues or something like that. I don't want that to actually live into the message engine. I wanted to leave that in a place that I have more control. In order to do that, now I have to create some kind of external repository. And I wanted to guarantee that that message then is actually stored into the repository, and the result of that is kind of a message with a specific token. that I can store into the message engine, and when the receiver gets that message, then it can go to the data repository with that token or that claim and request the message back. So the message comes back to the receiver. And we have ways to implement that on AIS, right? So the idea is that both the claim check sender component and the claim check receiver component can create in a way that is quite generic and can use some of those services that we talked before. So we can use the API management both for the sender and for the receiver to create a unique service interface and compose an API that is reusable across multiple systems, and have logic apps behind the scenes to store the data and safely give you a unique identifier of that particular message. So with two components from AIS and a little bit of the coding and configuration, you should be able to implement this claim checked pattern. The other thing that is interesting here is that same service can be applied, or the same pattern can be applied both to Azure Service Bus or to Event Grid as a model, right? Both of them has restrictions on how is the size of the message that I can pass through. So there is quite a useful pattern to implement, and implementing in a way that is reusable, so you can use multiple times inside your systems. The last pattern that we're going to be talking about is the Sequential Convoy, and then after that we can go and have a little demo on this one. So on the Sequential Convoy, what you have is the idea of multiple messages are arriving, and those messages are related between themselves. For example, A1, A2, and A3 needs to be processed in sequence because they are related, and B1, B2, and B3 also need to be processed in sequence because they have some kind of a relationship. But the problem is those messages are not necessarily arriving on the system in the order that they need to process. One option would be to have multiple queues, one for each one of those messages, but sometimes that is not possible because you would end up having too many queues to manage. Instead of that, what you want is having a way to identify those messages as belonging to a specific group or session, which is the name of that grouping that they give on this, and have a way for the receiver to request a specific session inside the handler. So when you're doing that, you break the original idea of every message that arrives goes in order to now say every message inside that group needs to be processed in order, or every message inside that session needs to be processed in order, right? So with that now, if I know how to identify those groups or sessions, I guarantee that I can go and request my session 1, and all the messages from session 1 comes in order and are processed in order, and all the messages on the session 2 are received in order. So the AIS implementation for that is based in two things. One, Azure Service Bus has natively the ability to enable queues and topics with the session information. So if you want that, you can say that particular queue or that particular topic has sessions enabled. If you do that, then every time that you pass a message, even if it's a message with just one item, you need to identify the particular session, right? On the other hand, on the client side, you're able to create a logic app that consumes the session and ask for every other message from the session. this pattern is so common, is so useful, that you actually have a Logic Apps template created for that. So we're going to see later on how to find that template and how that template is composed of. So now let's take a look at the patterns in practice, right? So let's take a look at a demo of some of those things. And what I wanted to show you guys is the claim check pattern, then the sequential convoy template. Just take a quick look of how that Logic App is created. We're not going to be running that. The claim check pattern are going to be running to the end, right? I actually show you how to implement that. And have a quick tour on the messaging filter. See what is new on Azure Service Bus and how you can find exactly the same things on Azure Event Grid. So, as we said, the first thing that we're going to be looking as a demo is how to implement the claim check pattern. So to make it a little bit easier, I replaying the message or the picture here. And on our design, we're saying that a sender, some kind of application, would be integrating with API management in order to put the data in the data repository. And a Logic App would be doing the actual work of connecting to a data repository and writing the things and coming back, while the API management would be the interface for us. Once that message would be ready to be sent, then the sender would send the message to the message engine. And on the other side, when a receiver application is picking up that message, it would first contact to the service bus once it receives that message, grab the message on the data repository, and for that Logic Apps would be giving that information to you. And once that message is the original message is back to the receiver, it would be processing that. So our client today is going to be represented by a Logic Apps called client sender. Our receiver is going to be represented by a Logic Apps called client receiver. So if you look at the client sender, for example, and take a quick look at what it does, it basically when it receives, when it's initiated, it's going to be call the claim check service, and once that claim check service is executed, it puts the message on the message engine, and in this case we're going to be putting that on Service Bus. The client receiver on the other side, when a message appears on that queue, it is going to be using the pick lock. So it gets a copy of that message, then it tries to first process that. And in this case, what it's going to do is looking at the message that you're receiving. If the message looks like a message for the claim check pattern, then after it receives that message, it's going to be calling the get original message from the claim check service, and finally it's going to be posting on system B, that is like processing that message, which is our hook bean system. If all of that works, then it can complete the message in the queue. If anything goes wrong in this process, it can go and abandon the message on the queue, which will guarantee that the message can be tried to be reprocessed later on. So things starting to get interesting when you're looking at how the API management and the Logic Apps are working together for that to be implemented. So if you look at the API management, we have an API called Claim Check API with two operations. One operation is post message to the repo, and the other one is get operations from the repo. The post message to the repo basically just interacts with the Azure Logic App, but that gives you a really nice way to encapsulate all that logic and should do any kind of messaging if you wanted before the message go to the backend service. The GET operation is an example of how we can actually use API management to our advantage. Logic apps in this case would be expecting to receive a message in the normal JSON schema, but for us it would be much better if the message was just a GET having a message type and an item ID as parameter, as part of the path of the API call. So behind the scenes, what we're doing on that is receiving after we receive the results, I'm getting the parameter message type, the parameter item ID, and I'm replacing that into a new message body that is an actual JSON body. And this is what is going to be sent to Logic apps behind the scenes. Then the two Logic apps, the claim check sender is the one that stores stuff on the repository. It's quite simple. It receives the message, it initializes a unique identifier for that specific message that you receive. You store that on blob, and then you respond passing that unique ID plus the original message ID and the message type. If anything goes wrong, it returns a failed code. And the claim check receiver does something similar. When it receives the call, it tries to get the message based on message type and item ID, and responds with the content of that message. Okay, so let's try to see that running. So what I'm going to do at this stage is I'm just going to send a message to that Logic app, call this is a sample message for Scottish Summit 2021 at 10:19 p.m. If you send this, it's just going to be received accepted. So yes, the message went through. But if you look at the client sender and look at the execution at 10:19 p.m., you're going to see that I receive a message of type sample message with a message ID of ABC12345 with the payload that we sent. That message went to the claim check service, came back with that unique identifier, starting with 5F, and the message was sent to Service Bus. If you look at the other side, now on the client receiver, shoot a message around 10:19, so it's quite fast to turn around. And we receive a message on that queue of the type sample message. We double check that the message that we receive matches item ID and message type, right? So we have item ID, message type, and message ID, which is the items that we needed to provide to the service. Then we call the service, receive the original message back, and post that to system B, which means that now we should have a new message here at 9:19 with the right values. And just to complete that particular demo, we can see that inside the claim check repo, we have a container called Scotch Summit, which is where I'm storing that. That's my claim check repo. And I have a sample message folder with a message created at 10:19:54. So if you look at that message and try to open, that message is exactly the message that we sent, right? And just to make it easier to read, there we go. So this is the first demo, and that's looking at the how to implement the claim check button, right? The other two demos are quite quick, right? The first thing I wanted to show you is, if you're interested in creating a claim check, sequential convoy, and you don't know how to start that, you should be able to create a new logic app. That goes somewhere. So this is sequential convoy sample. Just create that for now. That is going to create an empty logic app for me. And there we go. So if you go to that resource and one of the templates, and the template that we're looking for is on enterprise integration, correlated in-order delivery using Service Bus sessions. So this is going to be created on Service Bus to Service Bus, and we should be able to use this template. So for that, you need to create a Service Bus connection. And once it creates the connection, you should be able to see how the template works. So on this template, when a message is received in a queue with a next available section ID, it initializes, then it sends a message somewhere, if it's successful, it completes the initial message, otherwise it abandons, it breaks it down. And after that, it keeps renewing the session lock, so to guarantee that the session is still available when it's continue to pick up. And here, it's going to get the next message of that same session. So you should be able to deploy that logic apps on your system and just take a quick look on how that works. But you can see that it's quite a comprehensive logic app, and it's all implemented for you and you should be able to just decide where you're going to be inserting your business logic. For example, after you receive the message, in this case it's sending to a topic, but instead of sending to a topic, you could do your own business logic here, or call your own logic app. And the same thing would happen for the other ones. So this is the Sequential Convoy sample. And to complete our samples, one thing I would like to show you is inside inside the service bus. If you create a new topic, like the test topic, you should now be able to see the Service Bus Explorer. And the Service Bus Explorer now gives you the ability to send, receive, and pick messages. But most interesting here is when you click in on the subscription and you add a new subscription, that you look at subscription, you now have the ability to see the filters and to add new filters. So with this, you should be able to create a filter and manage your filters inside Service Bus, something that you didn't have the ability to do before. If we go to any event grid, and get that event grid, for any one of the subscriptions that you have associated to that event grid topic, you should also be able to see the filters. So on both cases, you're able to implement publish subscriber in a very simple way, just by using the events or the filters on both Service Bus and on event grid. Okay, so now that you have a quick look at the demos, now just to finish, I would want to give you some summary of the things that I think that is most important for you to take out of this session. So the first thing is, as you see, AIS support all the integration patterns that you're used to. I talk about 4 of the most common ones, but based on what I show you, most of the patterns that we used to do or that you needed to implement, you should be able to implement inside AIS. The main thing for you as a developer or an architect is to understand what are the message sets provide, so you don't have to reinvent the wheel, and what you can implement out of that to create those patterns, ideally in a reusable way. Remember that other services like Logic Apps, API Management, Azure Functions that we didn't touch here, but it also works quite closely to those ones, can help you to compose those patterns in a way that is quite reusable. And with that, this is the end of my presentation. Thank you very much. Just remind you that the slide deck is going to be uploaded at the end of the session, so if you want it, you should have access to that as well. And I'm going to be online during that presentation for you guys to ask any questions. Hopefully you enjoy. Thank you very much, and until the next time.